Hi folks, this is Calc 2, Checkpoint Quiz 15. We're given a function f of x represented as a power series, and in part A we're asked to find the interval of convergence of that power series. In other words, we're looking for its domain. So we're looking for all values x so that when I substitute them into this formula, I get a convergent power, or I get a convergent infinite series. So the tool we use here is the ratio test. And so I'm going to take the limit as n goes to infinity of the absolute value of the terms an plus 1 over an, which we've talked about in class. We're just going to rewrite this as the absolute value of an plus 1 times the reciprocal of an. So an plus 1, I would take all the n's in here and replace them with n plus 1. So this gives me the limit as n goes to infinity of the absolute value of negative 1 to the n plus 1, x plus 2 to the n plus 1, over 3 to the n plus 1 plus 1, or n plus 2, times the reciprocal of an. So I'm just going to take 3 to the n plus 1 over negative 1 to the n, x plus 2 to the n. So this is the limit as n goes off to infinity. The absolute values are going to take care of the negative 1's. I'm going to have an absolute value of x plus 2 to the n plus 1 divided by x plus 2 to the n. And then I don't need absolute values around these 3's. I'm just going to have 3 to the n plus 1 over 3 to the n plus 2. So I get the limit as n goes to infinity of, simplify this, I get the absolute value of x plus 2. 3 to the n plus 1 over 3 to the n plus 2 is going to leave me with a 3 in the denominator. And I see that all the n's have disappeared, and so I just get x plus 2 over 3. Now, according to the ratio test, I know that if I force this to be less than 1, the series will converge absolutely. If this ratio is greater than 1, then the series diverges. And if it's equal to 1, I'm not sure what's going on. All right, so that's our next step, is we're going to force our answer, x plus 2 over 3, to be less than 1. So in other words, x plus 2, an absolute value, has to be less than 3. So if I use my intermediate algebra, I get x plus 2 is between negative 3 and 3, or subtracting 2 gives me that x has to run between negative 5 and 1. All right. So our interval of convergence is going to be centered at negative 2, and we can go 3 units either side. So that gets me up to 1 and down to negative 5. So this is the radius of convergence here, is 3. So as long as I pick any real number between negative 5 and 1, this power series will converge absolutely. That's what the ratio test says. If I pick any number that's bigger than 1 or less than negative 5, this ratio would be greater than 1, and that diverges. So the only things we don't know about yet are what's going on at these endpoints. We just have to check them on a case-by-case basis. So for endpoints, let's plug in x equals negative 5. So I'm replacing x in my formula for f of x. And then I simplify. So I've got negative 1 to the n there. This gives me a negative 3 to the n over 3 to the n plus 1. And there's an opportunity here to simplify. I've got negative 1 to the n, negative 3 to the n. Now there's actually 2 ways I can simplify. I can write this as 3 times 3 to the n, and then I can simplify this way. I've got the same exponent. So negative 3 to the n over 3 to the n is negative 3 divided by 3 to the n, which is negative 1 to the n. So that gives me a negative 1 to the n times another negative 1 to the n over 3. And now that I have the same exponent here, negative 1 to the n times negative 1 to the n is, well, negative 1 times negative 1 to the n, which is 1 to the n, which is 1. So I'm adding up 1/3 infinitely many times. This is going to diverge. Okay. The nth term test, well, the nth term is always 1/3, and that never goes to 0. So that tells me I have to exclude negative 5 from the domain because it doesn't add up to a real number. Let's check the other endpoint. The other endpoint was positive 1. So I get the series n equals 0 to infinity, negative 1 to the n, 1 plus 2 to the n over 3 to the n plus 1. Gives me the series n equals 0 to infinity, negative 1 to the n, 3 to the n over 3 to the n plus 1. And I can simplify as before. I can rewrite that denominator as 3 times 3 to the n. And then the 3 to the n's cancel out. So we have to figure out if this series converges or not. Now you might say, oh, it converges, it's an alternating series. Well, not all alternating series converge. Okay, if you write this thing out, then it's 1/3 minus 1/3 plus 1/3 minus 1/3 plus 1/3 minus 1/3. So if I look at the nth term test, it's either 1/3 or negative 1/3, which means it doesn't go to 0. And so this, once again, diverges by the nth term test. All right, so what does that mean? The interval of convergence of f of x is just going to be from negative 5 up to 1, and I have to leave off both the endpoints. So that'll do it for part A.